Hello everyone, you're welcome to solve this nice radical math problem, which is the square root of 81 to power 2 plus 25 to power 2 plus 14 to power 4 divided by 2. So the first thing to do here, we can express 81 as 9 squared raised to power 2, then plus 25 can be expressed as 5 to power 2 raised to power 2, then plus 14 raised to power 4. All this divided by 2. Now the next step here, we have square root of 9 to power 2 raised to power 2, then plus 5 to power 2 raised to power 2, then plus, we can express 14 as, this is the same thing as 9 plus 5, all this raised to power 4 divided by 2. The next step from here, we can say let A be equal to 9 and let B be equal to 5. So let's substitute this. So here we'll have the square root of, this is the same thing as, remember this is 9, or this is the same thing as A squared to power 2, then plus, this is B squared raised to power 2, then plus, this is the same thing as A plus B raised to power 4 divided by 2. So the next step here, we have the square root of, this is the same thing as A to power 4 plus B 2 times 2 to power 4, this is B to power 4, then plus, this is the same thing as A plus B raised to power 4. All of this divided by 2. Now here we have the square root of A to power 4 plus B to power 4 plus, now here we have A plus B raised to power 4. Now to solve A plus B to power 4, we are going to apply binomial expansion theorem, so that now from here we'll have, if you have A plus B raised to power n, now if we start with A plus B raised to power 1, then essentially here we'll have the coefficient of A and B. Now if it is A plus B raised to power 2, then we'll have here 1, you add here 1 plus 1, which is 2, and then 1. If A plus B raised to power 3, you will have 1 plus 2, this is 3, 2 plus 1, this is 3, and then 1. If A plus B is raised to power 4, then here we'll have 1. If A plus B is raised to power 4, then here we'll have 1 plus 3, this is 4, then 3 plus 3, this is 6, and then 3 plus 1, this is 4, and then 1. So these are the coefficients of A plus B to power 4, which you can write as, now this will be the square root of A to power 4 plus B to power 4, then plus, here we're going to have A to power 4, then plus, we have 4, A to power 3, then multiplied by B, then plus 6, A to power 2, then B to power 2. You can see that B is increasing. Then plus, we have 4A, then B to power 3. And then lastly here, we'll have B to power 4. Then all this divided by 2. All this divided by 2. So this implies that here, this is the same thing as the square root of, we have A to power 4 plus A to power 4. So this is 2A to power 4. Then plus B to power 4 plus B to power 4. This is 2 b to power 4, and then plus we have 6a squared b squared, and then plus we have 4 a to power b to power 3, and then we have 4a to power 3 b. Then all this divided by 2. So as you can see here, we have 2 is common here. We can factor out 2. So let's factor out 2 here. So that now here we'll have 2 into the parentheses. We're going to have a to power 4 plus b to power 4. Then plus we'll have here 3 a squared b squared, then plus 2 a to power 3 b, then plus 2, we'll have here 2a b to power 3. All this divided by 2. So let's divide both sides here by 2, so that now we'll have the square root of a to power 4 plus b to power 4 plus 3a squared b squared, then plus 2a to power 3, then b, then plus 2a b to power 3. So the next step here, we can express this as the square root of, this is the same thing as square root of a to power 4 plus b to power 4, and then plus, we can express this as 2a squared b squared, then plus a squared b squared, then plus 2a cubed b, then plus 2a b to power 3. Now, from what we have here, this part, as you can see, we can express this as the square. We can express this part a to power 4 plus b to power 4 plus 2a to power 2 b to power 2. We can express this as, that is a squared plus b squared, close the bracket here, then plus, this is a squared b squared, which we can write as a b squared, then plus, now 2a to power 3 multiplied by b plus 2a multiplied by b to power 3. We can factor out 2ab into the parentheses. This is the same thing as a squared plus b squared. Now, as you can check here, we can just have let x be equal to a squared plus b squared, and let y be equal to, we can express y as ab. So this implies that we can substitute this back to the equation, and therefore you'll have the square root of, this is the same thing as square root of x squared. Here we'll have x squared plus, now here we'll have y squared, then plus 2xy, which in this case we can express this, that is x squared plus y squared plus 2xy. This can be expressed as, this is the same thing as x plus y squared. Let's substitute this. So we'll have here the square root of x plus y squared, and this implies that we can eliminate the square root sign by simplifying here, so that we have x plus y. Now, we have x plus y. But if you recall here, x is the same thing as a squared plus b squared. So this implies that here we have a squared plus b squared, then plus y. Y is a times b. So plus a times b. But if you recall again here, we are saying that let a be equal to 9 and b be equal to, we are saying that let a be equal to 9 and b equal to 5. So this implies that here we'll have 9 squared plus 5 squared, then plus 9 times 5. So 9 squared, this is 81, plus 5 squared, which is 25, then plus 9 times 5, which is 45. So this is the same thing as 81 plus 25. This is 6, then 8 plus 2, this is 10, then plus 45, so plus 45. So here we'll have, this is 11, carry 1, this is 5, and then 1. So the solution to this radical problem is 151. This is the solution. So kindly follow the steps, like this video, and subscribe. Kindly like and subscribe.